Okay, so we're back with another example of kind of how the Pythagorean theorem is related to the distance formula. And so with that, we're just going to go ahead and get started. We're asked to find the length of line AC here. And probably the easiest way to do that is going to be to use the Pythagorean theorem. Call the bottom A, the side B, and then the hypotenuse is always going to be C. We'll do A squared plus B squared equals C squared. And A is 1, 2, 3, 4, 5, 6 units. B is 1, 2, 3, 4, 5, 6, 7, 8 units. And we just do the math. 36 plus 64 equals C squared. That's 100 equals C squared. We'll take the square root of both sides because that's the inverse operation of squaring something. And we get 10 is equal to C. So what happens if we take the grid away? We can't count how long those sides are anymore. Well, I think we could still use A squared plus B squared equals C squared if we got a little bit creative. And the way we're going to get creative is by looking at, on the A side, that's how far those points are apart. The distance between 3 and 9. We know the distance between 3 and 9 is 6. We already had 6 for A up there. But we're going to actually write that out. We're going to say the distance between those 2 points is 9 minus 3, which we know is going to be 6. But again, this is just for an illustration. And that would be our A value, and that would need to be squared. And then for the B value, we would look at how far is it in the Y values from 2 to 10, because we're going up. And so the distance between 10 and 2 is going to be 8, just like what we had up there. And that's going to be equal to our C squared. So 9 minus 3 is 6 squared. 10 minus 2 is 8 squared. And that's equal to C squared. So we end up with exactly the same thing we had before. So we're going to go through this quick. 36 plus 64. C squared, 100. C squared. Square root of 100. Square root of C squared. 10 is equal to C. So that was pretty easy because we were able to subtract the x values to get the 6, and then we subtracted the y values to get the 8. But what if we didn't have a diagram at all? And all we were given was find the distance between those 2 points. This is where the distance formula really shines and is better than the Pythagorean theorem for figuring things like this out. And so at this point, I'm just going to throw the distance formula on here. The distance formula says x2 minus x1 squared plus y2 minus y1 squared is equal to d squared. Now again, I want to draw attention to how this is very much like the Pythagorean theorem. The x2 minus the x1 is just like saying 9 minus 3 making 6, which is the same as our a squared value. The different color. I'm not sure what's going on here now. Okay. So the y values, y2 minus y1, the 10 minus 2 gave us the 8. And so that is just like our b value. And then we're just replacing c squared with d squared because we're not talking about a triangle anymore. We're talking about the distance between 2 points. And so what I'm hopeful that you're understanding is that the distance formula is exactly like the Pythagorean theorem. Just instead of an a and a b, we have an x2 minus an x1. We have a y2 minus a y1 because we're just subtracting to find out how long these lines are instead of counting spaces on a grid. So with that, here's what we need to do. Every single time, and I mean every single time, if you don't do this, you're going to fail. We need to name our points. That's our x, that's our y. That's our x, that's our y. But if I said, hey, what number is x? You'd say, I don't know, which one are you talking about? 3 or 9? And if I said, hey, which one is y? You would say, I don't know, it's 10 or 2. So that's where the 1 and the 2 come in. If I say which one is x1, you know it's 3. If I say which one is x2, you know it's 9. And so we just use those sub numbers to help us identify which number we're talking about. And the order here doesn't matter. You could name the first set, the 3 and the 10, x2, y2 if you wanted. You could name the other one, the 9 and the 2, x1, y1 if you wanted to. None of that's going to matter. All you need to do is every single time label x1 and y1 together and label x2 and y2 together. Then all we need to do is substitute that information into the distance formula, and bing, bang, boom, we got it. Something important about the distance formula, though, that's going to be really helpful to you is if you write everything that is not the x and the y values, especially including that minus sign. Because what's going to happen sometimes is you're going to get a y value, for instance, that's negative. And if you have a negative y value like negative 3 minus negative 8, what happens a lot of times is people accidentally just write negative 3 minus 8, and they forget about that negative because there was already a negative there, and so they think, oh, I put negative 8. So my suggestion is that you always put this template together, like I have right there, before you put your numbers in. It will help you out a lot. So x2 minus x1 is going to be 9, minus x1 is 3. That's why it's super important to label. Y2 is 2, y1 is 10. So we do a little bit of math. We get 9 minus 3 is 6 squared plus negative 8 squared. You might be thinking, hey, Schlegel, something's up. We have a negative 8 there, and up here we had a positive 8. Something bad's going to happen. Let's find out. It's not going to matter because 6 times 6 is 36, and a negative 8 times a negative 8 is a positive 64. So it will always fix itself. Nothing to worry about there. We end up with the same thing we had before. 100 equals d squared. Square root of 100. Square root of d squared. 10 equals d. So that's going from straight up Pythagorean theorem to, hey, what if I didn't have a grid and I needed to figure out how far it was between those values, to straight up, here are some points, find the distance between them. Recognize that all three of these would represent the same exact triangle if we put them on a grid. We're just trying to get to the place where we can do this and find distance between points without needing to draw a triangle and without needing a grid.